double angle cosine formula. Let's derive it. We're going to look at triangle AMO, and the cosine of that is y. So cosine is just adjacent over hypotenuse. The adjacent side of that triangle is y, and the hypotenuse is 1, so y over 1 is just y. If we look at this other triangle, the cosine of 2 theta is the adjacent side to the 2 theta, which is w, divided by 1, which is just w. So let's put those on the side for a second. And let's look at this big triangle, triangle ABC. For that triangle, the cosine of that is the adjacent side, which is 1 plus w, divided by the hypotenuse, which is 2y. And if we substitute our y and our w that we derived earlier, we get cosine of theta is 1 plus 2 cosine of theta, or 1 plus cosine of 2 theta divided by 2 cosine of theta. I can multiply both sides by 2 cosine of theta and get 2 cosine squared of theta is 1 plus cosine of 2 theta. And now to get the cosine of 2 theta by itself, I just subtract 1 from both sides. And that is what I get. Cosine of 2 theta is 2 cosine squared of theta minus 1. That's one of our key double angle formulas for cosine. But there's 2 more. So that's the one we just solved. Cosine of 2 theta is 2 cosine squared of theta minus 1. I also know that sine squared of theta plus cosine squared of theta is 1. That's one of our key trig identities. And if I solve for cosine squared of theta there, I just move the sine squared of theta to the other side, and I have 1 minus sine squared of theta. Now, let's take the cosine of 2 theta formula that we just used. So that's 2 cosine squared of theta minus 1, and plug in what we got for cosine squared of theta from the other formula. So we know that's 1 minus sine squared of theta. And we've got that negative 1. We distribute. We have 2 minus 2 sine squared of theta minus 1. Combine the 2 and the negative 1, giving us 1. So cosine of 2 theta is also 1 minus 2 sine squared of theta. That's our other formula. And again, let's go with our basic. Cosine of 2 theta is 2 cosine squared of theta minus 1. Plug in that should be a negative. So there should be parentheses around this sine squared of theta plus cosine squared of theta. So we know 1 is sine squared of theta plus cosine squared of theta. And the negative is going to distribute. And I'm going to get cosine squared of theta minus sine squared of theta is cosine of 2 theta. So that is the last formula. And all 3 of those can be used depending on the situation. In fact, the IB Math SL trig formula sheet has all 3 of those formulas. So when you look at the double angle formula, and it's written kind of funny, cosine of 2 theta is cosine squared of theta minus sine squared of theta, which is the same as 2 cosine squared of theta minus 1, which is the same as 1 minus 2 sine squared of theta. Let's apply that. Example 1, given that sine of theta is 3/7, let's find cosine of 2 theta. So we're given sine, so let's just use the cosine of 2 theta is 1 minus 2 sine squared of theta. Plug in the 3/7 for sine of theta. 3/7 squared is 9/49 times 2 is 18/49. 1 is 49 over 49 minus 18 over 49 is 31 over 49. So pretty straightforward. Notice that whenever we use any of the double angle formulas for cosine, I'm always squaring. So it's not as important to know which quadrant you're operating in. With the double angle formula for sine, it was, but for cosine, it's not. Given that cosine of theta is negative 5/7, find cosine of 2 theta. So we're given cosine, so let's use the formula that actually uses cosine. Cosine of 2 theta is 2 cosine squared of theta minus 1. So 2 times negative 5/7 squared minus 1. And notice the negative 5/7 is inside parentheses. So when I square that, that's going to be positive. So I'm going to get 25 over 49 times 2, which is 50 over 49. 1 is 49 minus 1 is 49 over 49. So I'm going to get 1 over 49. That's the cosine of 2 theta. Last problem. I'm given that sine of theta is negative 3/5, and we're going to be in quadrant 3. So my theta is between pi and 3 pi over 2, and I want to find tangent of 2 theta. Now, here is why we actually need the quadrant for this one. Because tangent of 2 theta, I'm going to need both sine of 2 theta and cosine of 2 theta. So since I will need both of those, I have to find the other one. So I have to find cosine of theta. Sine squared of theta plus cosine squared of theta is 1. I know sine of theta is negative 3/5. So when I square that, I get 9/25. And I'm going to go ahead and save a step and just move that to the other side. So cosine squared of theta is 1 minus 9/25. Cosine squared of theta is 16/25. I am in this quadrant. I am in quadrant 3. So my cosine of theta here is going to be the square root of 16 over 25, and it's actually going to be the negative 1, since both the cosine and sine in that quadrant are negative. Cool. So now we know that sine of theta is negative 3/5, cosine of theta is negative 4/5, so I can find everything else. So let's find sine of 2 theta first. Sine of 2 theta is 2 sine of theta cosine of theta. I plug both my sine of theta and cosine of theta in, and get sine of 2 theta is 24 over 25. Cosine squared of theta, I can pick anyone I want to. I'm just going to go with 2 cosine squared of theta minus 1. Plug in my cosine squared of theta, get 16 over 25 times 2 is 32 over 25 minus 25 over 25. That's my 1. And I end up with 7 over 25. So now I've got my sine of 2 theta. I've got my cosine of 2 theta. I can put both of those over one another. So tangent of 2 theta is sine of 2 theta over cosine of 2 theta. I don't know why I just rewrote that. But 24 over 25 divided by 7 over 25. If I flip and multiply, or I can just notice that I can just get rid of the denominator since they're the same thing and end up with 24 over 7. So with a problem like that, when I'm looking for tangent of 2 theta, I need the sine of 2 theta, I need the cosine of 2 theta, I've got to work everything out, and I end up with 24 over 7. And that is my answer.